Hello everyone, this is your host, your friend, your boy, Jet Black, the one and only, here with another exciting video, and in this video I'm going to be reading the following NBC News article titled, "Scientists are searching for a mirror universe. It could be sitting right in front of you." I hope you guys are excited to hop into this article with me. This is going to be me reading the article, me reacting to the article, and I definitely want to hear your thoughts on the article in the comment section below and on our Discord. Link to the Discord is in the description. Okay, let's hop right in. If the mirror universe exists, or if the mirrorverse exists, upcoming experiments involving subatomic particles could reveal it. At Oak Ridge National Laboratory in eastern Tennessee, physicist Leah Broussard is trying to open a portal to a parallel universe. So right off the bat, I've already read this article. So this is me rereading the article in order to react to it with you guys. But this is kind of this first sentence. This is definitely something that's meant to hook you into the article, make you go like, what? And like have you like keep reading, but no. She's not trying to open a portal to a parallel universe. At most, what she's trying to do is like determine whether or not such a parallel universe actually exists. But let's keep it going. Let's keep reading through the article. But it's interesting rereading an article and immediately going, well, that first sentence was a lie when you see the whole thing. She calls it an oscillation that would lead her to mirror matter. But the idea is fundamentally the same. In a series of experiments she plans to run at Oak Ridge this summer, Broussard will send a beam of subatomic particles down a 50-foot tunnel, past a powerful magnet, and into an impenetrable wall. If the setup is just right, and if the universe cooperates, some of those particles will transform into mirror image versions of themselves, allowing them to tunnel right through the wall. And if that happens, Broussard will have uncovered the first evidence of a mirror world right alongside our own. It's pretty wacky, Broussard says of her mind-bending exploration. The mirror world, assuming it exists, would have its own laws of mirror physics and its own mirror history. You wouldn't find a mirror version of yourself there, and no evil Spock with a goatee. Sorry, Star Trek fans. But the current theory allows that you might find mirror atoms and mirror rocks, maybe even mirror planets and mirror stars. Collectively, they could form an entire shadow world, just as real as our own, but almost completely cut off from us. Okay, so hold on a second. Earlier I was like, that's cap. She's just trying to figure out if such a world exists. But now, reading a little bit further, I'm like, okay, well, maybe it does kind of sound like a portal. So when I read this full article, my takeaway was like, okay, the idea of the experiment is just to discover if there are any like mirror particles or whatever. And if you discovered the mirror particles, then it would allude to the existence of like the mirror universe. But the way that they describe the experiment when rereading it again, it mentions that like the particles are shot through a magnetic field and then they kind of like phase into like mirror image versions of themselves that then tunnel through the wall. So maybe you could see that as a portal and you may be like, how is that a portal? Well, it sounds almost like the particles would go into the mirrorverse and then come back out through the wall, if that makes sense. So I'm like, oh, I guess that kind of is a portal in a way. I was thinking based on the way that they describe the mirror particles or whatever, that it's just more like the mirror particles don't give a fuck about the wall because they're like not a part of our universe or whatever. But I guess that makes sense. It is kind of like a portal. But when I think of a portal to another universe, I think of like sliders where like you would walk through a portal and now you're in another universe. But technically, I guess, yeah, if you're shooting the particles up at a wall and then they like zoop, like into the mirrorverse and then zoop onto the other side of the wall, then yeah, I guess that is a portal to another universe in a way. And yeah, that is some pretty crazy stuff. What do you guys think so far? What do you think of the concept of it being called like the mirrorverse? I think that's kind of weird. It's a When I think of a mirror world, I think of what you saw on like the Flash TV show last season, where there's literally just another reality that exists inside of mirrors. Or I do think of it as like oh, it's an opposite world to our own, Why wouldn't you just call it like a parallel universe? Mirror world is such an odd terminology, I guess. They also call it like a shadow world, like in another part in the article. And shadow world makes me think of like if you could enter the world of shadows, like literally like shadows you cast on the ground or whatever. So there are all these different ways of just saying parallel world or parallel universe, but I don't know why all these different words are being used. I kind of get why we call it a mirror world because we call them mirror particles, but then I don't even know why we call them mirror particles. Maybe because parallel particles doesn't sound right. Why don't we call them like multiversal particles or something if we're implying the existence of like mini worlds or something? I don't know. I always have like weird gripes with certain terminology that's used. This is Leah Brossard, studies subatomic particles at Oak Ridge National Laboratory, where she will be searching for mirror matter this summer. Brossard says her initial search for the mirror world won't be especially difficult. This is a pretty straightforward experiment that we cobbled together with parts we found lying around using equipment and resources we already had available at Oak Ridge, she says. But if she unequivocally detects even a single mirror particle, it would prove that the visible universe is only half of what is out there, and that the known laws of physics are only half of a much broader set of rules. If you discover something new like that, the game totally changes, Brossard says. 10 minutes, oh sorry, 10 seconds that rocket physics. Oh, I keep reading it wrong. My bad. 10 seconds that rocked physics. It's my imagination jumping in while I'm trying to read. My apologies. As with many grand scientific quests, the hunt for mirror matter grew out of a small, seemingly esoteric mystery. Starting in the 1990s, that's really not too long ago, physicists developed high precision experiments to study how neutrons, particles found in the nuclei of atoms, break down into protons, a process related to radioactivity. But those experiments took a strange turn. Researchers found that neutrons created in particle beams similar to the one that Brossard will use last 14 minutes and 48 seconds on average before decaying into protons. But neutrons stored in a laboratory bottle seem to break down a bit faster, in 14 minutes and 38 seconds. 10 seconds might not sound like much, but the actual difference should be zero. All neutrons are exactly the same, and their behavior should depend not one bit on where or how they are examined. I take discrepancy very seriously, says Benjamin Grinstein, a particle physics expert at the University of California, San Diego. It's not just between two experiments. It is a collection of many experiments done independently by several groups. The newest experiments, conceived in part to resolve the disagreement, have only made it worse, he adds. So it is curious to try and figure out how this connects back to the concept of there being some kind of shadow world, mirror world, or parallel universe, right? If this is what it's based off of. The idea that neutrons and particle beams normally last 14 minutes and 48 seconds, but if they're stored in a bottle, they decay faster. So now, as we read through the article, it should explain to us, right, how that somehow has something to do with a mirror universe, like advanced particle decay. So let's keep reading and see what comes out of that. Also, let's partake in this little poll. So they have a poll that says, do you think a mirror version of our universe might exist? Tell me in the comment section below and on our Discord whether or not you think a mirror universe exists. I'm going to say, I don't see why not. There's just so much scientists have yet to discover. Because who knows? I mean, I really don't. They say I have a strong view. So, well, don't cover up the results. I'm trying to look at the... Get out of my way. So let's see. It looks like 11% of people lean more toward the idea of it being like science fiction, with 14% of people being kind of stuck in the middle, and with 76% of people leaning more toward the idea that there might be some kind of mirror universe. Let's see, and that's quick vote. That's a quick vote. Is that saying 27 out of 164 votes? There's not like a slash between these two numbers. Are they trying to say that it's 27,164 votes, like a whole bunch of people have voted. I don't know. They need a comma here or they need a slash because I don't know what they're trying to say with this like 27 space 164. Anyways, Grinstein has explored the possibility that some neutrons are unexpectedly breaking down into particles other than protons, but has found nothing so far. Mirror matter offers a more elegant, if somewhat bizarre, explanation. A decade ago, Anatoly Surobrov of Petersburg Nuclear Physics Institute in Russia introduced the idea that ordinary neutrons sometimes cross over into the mirror world and transform into mirror neutrons. At that point, we could no longer detect them. It would be as if some of the neutrons simply vanished. Okay? So he's trying to say that instead of neutrons just decaying faster in different storage, yeah, I'm trying to figure out how he gets to this jump. So we go from the concept that like neutrons should decay after being fired out of a beam for 14 minutes and 48 seconds or whatever, to saying that like when we see them in bottles, for some reason they decay faster in like 14 minutes and 38 seconds or 28 seconds, whatever the amount was. There's a 10-second difference. They decay 10 seconds faster in a bottle, to being like, okay, why do they decay faster in the bottle? And then you go, yo, easy game. They're not decaying faster in the bottle. It's just some of them inside of the bottle are actually going into another reality. And we can't detect them, so we think it's decay, but it's not decay. I guess I understand what he's trying to say. It's because we've already established that like there shouldn't be a difference in the decay rate in terms of storage. Where like the storage thing isn't really what matters. We're trying to figure out like, yeah, that's interesting. Okay, I kind of get what he's saying. So he's trying to say that like it's not a difference in decay. I feel like that's what everyone probably is thinking already. It's not that it's decaying faster. It must decay at the same rate because all neutrons are the same based on what they're saying. So what's happening to the neutrons that disappear is what we're trying to figure out. So the neutrons that are disappearing, I guess the concept is they must be going somewhere because they're not decaying, because if they were decaying, they decay at the normal rate. And then he'd be saying, well, if they're going anywhere, we can say that they're going to the mirror world. That's where they go. And so we never get to see them decay because they go to this like other reality. I don't think you could prove that, right? How could you ever prove that? I mean, it sounds like one of those like unprovable things because we know that they're, yeah, that's interesting to argue. We know that they're not decaying because if they were decaying, they wouldn't disappear as quickly as they are disappearing when we're observing them in the bottle. So if they're not decaying, then they're disappearing. And if they're disappearing, where are they going? But I don't think you can just make up a new place and just say they exist in another reality. How do you know that they're not like... I mean, a lot of different answers are very far-fetched, but it could just be that they're like appearing somewhere else within our own reality. And if you want to say like, because I can just make stuff up if you want to. We can do like play pretend. They went back in time. They went to the future. They like, you can do a whole lot of things before you jump to parallel universe. So I'm curious if there's any like connective tissue that makes you go, well, the only explanation is they must be going to some parallel reality. Let's see. Where was the last thing that I read? I'm just going to start over at the a decade ago thing and keep going from there. A decade ago, Anatoly Surobrov, I feel like I did a better time the first time I tried to read his name. Anatoly Surobrov of Petersburg Nuclear Physics Institute in Russia introduced the idea that ordinary neutrons sometimes cross over into the mirror world and transform into mirror neutrons. At that point, we could no longer detect them. It would be as if some of the neutrons simply vanished. That would make the neutron lifetime look wrong, Brossard explains, because some of the neutrons would have been disappearing from the test equipment while the researchers were studying them. Connect the dots and you reach a far-out conclusion. The neutron experiments might look screwy because physicists unwittingly opened a portal to the mirror world. Okay, how would you be opening a portal? That's the other thing, right? Are they saying that by shooting a stream of neutrons, these subatomic particles, that creates a mirror world portal? How does that explain the whole laboratory bottle thing? Is the portal inside the bottle? Why is it that normally they decay at a different rate? Yeah, I don't know. I don't know. I still feel like that's a reach to say that they're going into another reality rather than just saying that they're like somehow escaping the equipment. But I understand her experiment, the idea of having the impenetrable wall, because it's like saying, okay, how would they be physically like leaving this container that can't be penetrated? You know, if we create this like impenetrable container and we shoot the neutrons into it, none of the neutrons should be able to escape. They should just decay at their normal rate inside. So that makes sense. Let's keep looking through the looking glass. Brossard's goal is to find out if that portal really exists, and if so, to open it in a methodical way. That's where her neutron beam and impenetrable wall come in. Oak Ridge has an 85 megawatt nuclear reactor that can shoot out billions of neutrons on demand. So getting enough raw material to work with isn't an issue. The hard part is figuring out how to make some of the neutrons cross over into the mirror world, and then prove to her skeptical colleagues and to her skeptical self that it really happened. The hard part is figuring out how to make some of the neutrons cross over into the mirror world. Is that the hard part? That's kind of weird to phrase. So we're trying to figure out where the neutrons go, like where the neutrons are disappearing to. And we're trying to rule out means that make sense within like the reality that we live in, right? So she's like, I'm going to fire them into this impenetrable container where they can't get out. There's no way for them to get out. The thing that they could get out through is impenetrable. You can't get past it. And if we look at the neutrons and look at their decay rate, we know how fast they should decay. So if watching the neutrons decay, we notice that some of the neutrons are just not there. Like if it seems like it's decaying faster, then we know that somehow there are neutrons that didn't decay but just disappeared. It seems like she's just repeating the experiments that we've already heard about in the article. The main difference is saying, well, there's no way they could have gotten out. I like eliminated the like idea of them being able to escape. So if they escaped, they went somewhere. Where did they go? Mirror universe? Like it still doesn't tell you that the mirror world is like a hard and fast thing that exists. And I don't think the hard part is figuring out how to make them cross over into the mirror world. It seems like we've just seen that, like we've observed that in the past. It's more trying to rule out that they didn't just leak out of the bottle or something. You know, we're taking that laboratory bottle line that they said earlier, and we're just saying, well, what if that bottle was something you couldn't escape through any conventional means? Essentially introducing the concept that they're like escaping in some like really crazy way, maybe into some kind of mirror world, whatever that means. Running the experiment will take about 1 day. Collecting the data and weeding out every possible source of error might then take a few more weeks. Brossard is looking for any telltale neutrons that manage to get past the barrier by turning into mirror neutrons and then turning back. So the concept of trying to count neutrons that got past the barrier and then turned back into normal neutrons is weird. Because I don't know why that's the thing. Nothing was ever implied earlier in the article to say that in those previous experiments where they noticed that they were quote unquote decaying faster, but in reality some of them are disappearing because they can't decay faster because that's not a thing. Nothing implied that the neutrons that were disappearing were then coming back in any way. So I'm curious to see why that's even considered like an option. like something that could occur, or why that would even be something that we would be able to measure or be like trying to measure. Uh, I don't know. That's weird. I don't know enough about physics. I'm definitely curious what my friend Aiden would say about this. Aiden is really into physics. Let me know in the comment section below your thoughts on this. I could be misinterpreting all of this. I'm not saying that I'm an expert in any of this, but I definitely am curious about stuff like parallel universes and mirror universes. This will likely inspire like future like stories and like superheroes and stuff that I create. I'm definitely into this kind of thing. I just have a certain level of skepticism, if that makes sense. Let's see. Boom, 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 boom. It all comes down to, are we able to shine neutrons through a wall? She says. We should see no neutrons, according to conventional physics theory. If some of them show up anyway, that would suggest that conventional physics is wrong and that the mirror world is real. Does it mean that the mirror world is real? I don't think that's what that means. I don't know. Because the concept would be that the neutrons leave the space of the bottle and then enter the space on the other side of the impenetrable wall. And we don't know where they go in the middle, and the experiment doesn't explain where they go in the middle, so it still wouldn't prove that there's a mirror universe. It would just prove that they go somewhere. And I mean, it's weird to even say that there's like an in-between space where they go, right? At least in like fiction, you have the concept of like teleportation, where someone could be sitting here and then they could teleport into the kitchen. And it doesn't mean that they actually like went to some subspace between those two locations. It could just mean that they were in an instant from here to there. They're just like in the other space now. So that doesn't prove that there's some like other void that exists that teleporters go through. Depending on however the teleportation works, it could just be some kind of instantaneous movement where you cross space without actually physically going through that space. You're just there now. Again, that also sounds really wacky. I'm not going to say that that makes like more sense than a mirror universe necessarily, but I feel like it might be just easier to swallow. You can prove that the neutrons went through the impenetrable wall, but I don't think you can prove that they did so by entering another reality and then re-entering our own, if that makes sense. Well, let's see. I mean, what keeps you from just saying they went through the wall? Like, it sounds easier to say that the wall isn't impenetrable than it does to say that they, like, went through another reality to get past the wall, if that makes sense. Well, let's see. Meanwhile, Klaus Kirch is working on a complementary experiment at the Paul Scherrer Institute in Zurich. His plan is to capture slow-moving neutrons, hit them with a magnetic field, and then count to see if all the particles are still there. If some neutrons oscillated into mirror neutrons, they would disappear from our apparatus, he says. Kirch's team has already run the experiment and hopes to have their results analyzed later in the summer. Life on the Far Side. Despite their conceptual simplicity, both Broussard's and Kirch's experiments are extremely delicate undertakings, dependent on assessing the strange behavior of a few subatomic particles within a crowd of billions. Other researchers have proposed that there might be more blatant signs of a mirror world. We might be seeing it everywhere in the sky. Okay, I remember this part of the article being kind of weird. Okay, since the 1970s, astronomers have deduced that the universe is packed full of dark matter, a substance that cannot be observed directly, but whose powerful gravitational pull helps keep galaxies from flying apart. The latest analyses indicate that dark matter outweighs visible matter by a factor of 5, yet dozens of intensive searches by astronomers around the world have failed to identify what dark matter is made of. Zurab Berezi, I probably butchered your name. Zurab Bereziani, I still probably butchered your name. My apologies. I apologize to anyone whose name I had to say in this video. A physicist at the University of La Aquila in Italy. Also, I apologize to the University of Akia, I think Aakila. I don't know how to say the name. My bad. Who has conducted his own mirror neutron searches, offers an intriguing explanation. Dark matter has been hard to find because it is hidden away in the mirror world. In this view, dark matter and mirror matter are one and the same. If so, the mirror world is not just ubiquitous, it is far more massive than our own. At a recent physics conference, Berreziani expanded on the idea, outlining a possible parallel reality full of mirror stars, mirror galaxies, and mirror black holes, maybe even dark life. So, the concept that we can't find dark matter because it's in the mirror reality, which is such a weird. I don't like that we call it the mirror world. I already explained that, but now if you're trying to put dark matter into it, I'm also thrown because now they're trying to say it would be many times larger than our reality or whatever. Is it a mirror? If it's so different, it makes more sense to just call it like a parallel reality. But what do you mean it's hidden away in the mirror world? Because dark matter also just has an effect on expansion. How is it affecting our world where, while existing in the mirror world? It would imply that like our two different realities directly like interact with one another, but in ways to where you can't see the like thing that you're interacting with. Like you can't see the other reality, but you can interact with the other reality. That sounds cool conceptually. I could probably use that for like a superhero character idea. But I still feel like that's a reach. I still don't know how you like prove the existence of the mirror reality in any way. Dark people is probably a bit far-fetched, says Brossard. That's weird phrasing. I probably wouldn't have called them dark people. I get what she's trying to say. Who confesses that these ideas push her right to the edge of her comfort zone. But dark matter is very likely as rich as our own matter. This kind of thing needs to be explored. If she can open a passage to the mirror world at Oak Ridge, that will be one heck of a start. So yeah, we've read through the entire article. What did you guys think of the article? Do you think a mirror reality really does exist? And do you think these experiments actually would prove the existence of a mirror reality? Why or why not? Definitely let me know in the comment section below. And if you guys want to talk more weird science, feel free to hit me up on Discord. This is your host, your friend, your boy, Jet Black One Only, logging out. Peace, guys. Check it about.